Welcome to part 5 of the instructional video series on putting together the C3DT/C cantilever printer. In this video we will be putting together the y-axis, and the y-axis is the axis that will actually carry the bed back and forth on this printer. This video corresponds to step 4 in the instructable for putting together the C3DT/C printer on Instructables, and the link below the video. It will, however, also apply to several of the Instructables I have on the universal rail, because that's really what this is. This is a universal rail. All these components are used in the cantilever printer, but they could be theoretically used in any type of linear rail or actuator that you would use for your machinery. If we look at the parts associated, we have the 1010 aluminum extrusion, 1010 meaning this is 1 inch by 1 inch. We have the linear rail. In this case I'm using a linear rail that has the holes slightly smaller than the actual Instructable. So we have 15 by 20 millimeter, and we will have to, and there's parts available accordingly. I'm going to connect the linear rail to the extrusion with 7 T-nuts. You could go all the way and go, for 14, get one for every hole, but I've never really seen the need for that. The printed parts are the NEMA connector, the idler at one end, the little brake to prevent the linear rail from falling off the rail and losing all of its balls, the Y adapter to which we will be connecting the bed, and later on in another Instructable, NEMA 17 motor, a 20 teeth pulley that goes on the motor, a 20 teeth idler, and a spring, and this is the similar spring that you can find in the bed tensioning screws, which is actually incorporated into this rail, so it will be auto tensioning. The rail itself will actually tension the belt. And then approximately 860 to 900 millimeters of linear rail. In this video my axis is slightly longer than in the Instructable, and that's simply because I had to do with what I had around, which is this linear rail, which is longer than the 250 millimeter rail that's mentioned in the Instructable. This one is, I believe, 300 millimeters. So it's slightly longer, but the same principles will apply. Okay, so that wasn't all the parts. I missed one very important piece, and I pointed out in the Instructable, very important, do this first. This is the triple economy slide-in nut that is needed within this rail to actually attach it to the frame. So this should have been added prior to doing anything else into the linear extrusion. When we look at the rail here, in this side here, this is where this triple nut would have to be inserted, and I'll have to go back, loosen this up and add it in, because what will happen there is we will be adding this plate, triangular, to connect it to the actual frame itself. So, my bad, I will have to go back, unscrew this, get the belt out, and I can do that. If you unscrew the NEMA motor, it actually can move forward, and that will actually release the tension on the belt. So we don't have to remove the belt, we just have to kind of wiggle it out. But still, I have to go back and add this triple slide-in nut into this rail, because it is needed to actually connect the whole y-axis to the frame. And back to the video. We can start anywhere, really. What we will do is we will start putting together the NEMA motor and the pulley first. The NEMA motor will be positioned through the adapter right next to the belt. You can kind of do this by eye, but I do it by, I know that the space between the motor and the adapter here has to be about a millimeter, 1.55 millimeters. So that's where I'm positioning the pulley on this motor. And so the pulley has the two screws. Make sure that you screw them tight. And also, if you have the flat side here, the flange on your axis on the stepper motor, make sure that you have one screw pointing to the axis, because else there might be play later on once things start going back and forth. All right, so we're going to connect. Okay, so we've got that connected. The next thing we can do is we can add the NEMA adapter to the actual motor. Now we kind of have to figure out, this will be the y-axis. If we look at, if the printer was pointing with the y-axis, the motor would be sitting in the back. And so as far as wiring is concerned, we would want the wiring to point to the left, because that's where it will lead to actually get to the case. So we will add the adapter like so. For this we're using 16 millimeters to 25 millimeters. 3 hex nuts. I'm a big fan of the hex nuts. There's way less chance of, things going fraying or over screwing. You get a pretty tight connection with these guys. All right, so we are going to get. Okay, so that's tied on there. The next thing we'll have to do is we have to add the end stop to the case that's been provided for this one here, and there's a little, so these end stops might be off a little bit as far as length goes, and I've printed this fairly tight, so there's more likely that it won't fit. And the nice thing about these is these circuit boards, you can easily file off a little bit. This fits pretty tight. The other thing that you will notice is if you look at the back of these boards, the pins stick through a long way, and I did not print room for that because I don't want to print room for that. It's not needed. So what we'll do is we will actually chop these off with a wire clipper. And trust me, there's enough solder on there to not disconnect these, and then that way it will slide in. Again, like I said, this is a tight fit, but that's okay. So in this point we have the motor part for this rail done. And so what will happen is the rail will fit in here, and there's a little ledge in there. So you can make sure that it fits all the way through. And that will be one end of the rail. The next part that we can put together is the idler part. For the idler part, we're using this component, which is the idler printer part. We're using a 20 teeth idler, and the reason we use 20 teeth, and I've talked about this before, is that we need to get the belt. The belt runs through the actual aluminum extrusion, and we do not want to be hitting these edges. So by using a 20 teeth instead of a 16 teeth idler and pulley, by the way, there's enough room between the belts to run nicely between these slots here. So that's why we're using the 20 and not the 16 idler. If you use a 16 idler, you'll find that your belt's going to be scraping against the edge here, and this is some sharp stuff, so that's going to fray your belt real fast. All right, this one's fairly simple. We're going to put in the 25 millimeter M3 screw. No need to over tighten this. This is really just to keep the idler in place. So that sits fine there. Okay. Then the next thing that we are going to do is we are going to put the spring. So there's a cavity within this idler that will hold the spring. So that fits in there. And as you can see, Now this is the spring in there. Basically the wiggle room that we have. If we tighten the belt with this thing pushed in as best as we can, then the spring will push it outwards and tension the belt that way. This will go on like so, and as you can see right now there's quite a bit of room, but you can push this in so, and that would tension the actual belt. Okay, now so as far as the belt is concerned, this is going to be a bit tricky, because what we have to do is we have to add the belt and tension it. So what we're going to do is we are going to push in the rail as much as we can, measure the belt for the proper length, and then connect it in this little pulley. And the way this little, well, belt gripper I would call it, works is there's going to be a screw through here that once the belt is in will actually pull these two together and keep the belt in place. And thus far none of them have come loose for me, so that mechanism seems to be working pretty fine. We do want to cut this off straight, because what will happen is the belt will go like so in this block. Okay, but we need to get the exact measurement. So here's what I'm going to do. I'm actually going to weave the belt through, and we might have to use some tweezers for this to get it around. The actual pulley. There we go. I pushed it through. Actually, I did that wrong. We should be coming from the other way, because the belt gripper will be on this side towards me of the rail. Okay. This is a bit fiddly, but you know, all right, so that's one end, and then it will go through the extrusion and will end up over here. So now this belt is clearly too long, but that's okay. So what we are going to do is I'm going to let this rest for a second, and what I'm going to do is I'm going to temporarily create a little jig that will push the belt in as far as possible. I'm going to use a couple of wood blocks. I'm going to do this on the edge here. What I will do is I'm going to temporarily remove the spring and get this on. This would probably be a bit too much, but it's yeah. So I'm gonna put these blocks here, and then I am going to clamp these to the table at this distance. And then with the spring in, I can tension the blocks, or tension the rail between these two blocks. It gives me my hands free to work with the belt. Okay, so now we will put the spring back. Screw goes up there, and now make sure the belt is around. And now I am going to push this in and get it between these blocks. Now this puppy is fully tensioned. and I can start looking at where to cut. Right there is where I need to cut the belt. And now we are going to add this block. This is going to be a bit of a struggle because this is, again, a very tight fit, but with a little elbow grease, these will fit in here. There we go. That is one side. Make sure we push it all the way to the bottom, because the room within this, between this belt, is tight. This is as far as it goes in. What we can actually do is we can kind of trim the top layer off so there's no friction with any rail. Alright, that is one side. We're going to do the same thing for the other side. Things are getting very tight now at this point. But the same deal here. You have to kind of find the groove, and then the rest will follow. I'm going to push this in, and like we did before, I'm going to trim off the top edge so I'm not dealing with any friction against. This belt is strong enough. One of these little pliers is very nice to have, because it's very, you know, these things when they come new, they get dull real fast, but when they're new and sharp, it's very easy to cut things very accurately. Okay, so now I'm going to tighten this screw here, which will actually squeeze the block together and make sure that these rails, these belts don't come out. All right, and at this point we should be able to push this through. We have our gear block, and now if I release this from between the blocks, the spring will try to push out the block, and so we have a very well tensioned belt within this rail. So here we have a auto tensioning belt where the tensioning is built in through this screw. The next step is adding the linear rail. So the actuator itself is set up. Now we're going to add the rail. Like I said, I'm using longer linear rails than actually an Instructable, so my axis is actually also a little bit longer. I'm going to temporarily add this on here, and it fits over. I'm not going to assemble this fully yet, because we're going to add the bed on top of this, but for now I'm just going to use a, I'm going to get a The only reason I'm going to add this block right now is to make sure that the linear rail is positioned properly so that it meets the actual end stop here. This fits on pretty nicely. So let me do this. Attached. Now careful when you play with these rails, right? Because if this comes rolling off, there's a chance that most of these cheap ones don't have cages in there, so the bearing balls will just fall and fly all over the place. Okay. So this is where the rail would be, and we have to meet the end stop. This is perfect. I can pretty much, there's enough room left on this rail. So if we added at this distance, that's fine. We can pretty much meet the NEMA connector here for this particular rail, but that might be for your printer. You gotta have to figure out kind of where the block meets the rail, and that's at least as much rail that you need to have on this side to get there. Okay, so I know where the rail is supposed to go. I am going to remove this to the extrusion. This part could be a little bit finicky. We're using these M3 T-nuts that are according to the specs for either the 2020 extrusion or the 1010 extrusion that we have here. So the 2020 will be 20 millimeters by 20 millimeters, and the 10 by 10 or 1010 is 254 by 254, so basically an inch by an inch. Now the problem with these things is that when you add them into the rail prior and try to get screws in, you can make them meet, but the problem is when you start attaching them, they will start rotating freely underneath, and so you can keep turning until you see blue, but nothing's going to happen. What I'm actually going to do for this setup is I'm going to add the T-nuts, screw them in far enough so that when this ledge meets the extrusion rail, it can no longer turn freely, but hopefully will still grab onto the rail. The sad thing is that, this is easily verifiable for the last two T-nuts, but for the middle T-nuts, you have no view as to what's going on. So you kind of have to keep your fingers crossed that they are attached. Now, that said, it's not like we're trying to move a truck. We are simply trying to get the rail to hold on to there. So I'm kind of verifying how deep these have to be. If I now turn, it'll grab on. All right, so this is perfect. This distance. I'm going to do that for the 6 other ones. Okay. So we have all screws in place. We are going to wiggle this onto the rail. Now you want to tighten the first and the last ones first so you can actually line up the rail, and then make sure it doesn't go crooked. Now with this shorter length, that's the best way to approach it. Now they're on there, they're not super tightened, so the way you do this, you go this, 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 this. So you go, so try that again. I'm actually going to use something with a little bit more torque. All right, and there we have it. We have the rail. The last thing we're going to do is we're going to add this little brake block here. So we're going to, and this will click on. And that's, so the click on that you heard there, that's why it's important that you get the rail with the grooves, because these items, these STLs are printed with the grooves in mind, so they actually click in place when you add them. All right, I'm going to tighten this down. Not too tight because you're going to pretty much crack the plastic. Now when the rail comes over here, it's got nowhere to go, so it will not lose any of its bearings. We can add this guy back on. Should be a tight fit. There you go. That clicks on. Again, I'm not going to tighten this down yet because we will be adding the bed to this. But at this point, we have a operational Z-axis with the belt running inside the extrusion built-in end stop and built-in belt tensioning. So this belt is tensioned by the construction itself, so you don't have to worry about loose belts on this printer. The only thing that's left right now is for me to sleeve the wires, and I'll be using braided sleeving for this. This stuff is pretty nice. If we want to do it really nice, we would cut it off over here. This stuff really frays, so you one way to kind of keep this in place is to add shrink wrap or black tapes. Now the shrink wrap can handle the flame, but the braided sleeving actually does not handle fire very well, so careful there. The same thing here, we're going to put shrink wrap on this side. It's ready to be shrunk into place. You should try to kind of shrink it until you see the pattern of the weave come through the shrink wrap, and then you know it's really tied on there. All right, here we have it. We have the axes, or for those of you building anything else but the C3DT/C printer, the generic linear actuator with end stop built in, all put together and ready to be put on the printer when we are putting the printer together. That's it. If you like what you see, give me a thumbs up. If you really want to help me out, go to my Patreon account, the link below. I could certainly use the help. I do all of this for free. I got nothing in return. Any help is welcome. And the next video, we will do the same thing for the x-axis. However, the x-axis will have a loose or a disconnected end stop. Thank you and goodbye.